just want to do kind of an overview with all these transformations, and they just want to kind of go over just sort of what they all look like, the sort of the main ideas behind them. So the overview is like this. First off, we're going to have what are called vertical shifts. So the first kind of vertical shift is a shift up. So what you would do, have your original function, say it's a parabola like this, and to shift it up c units. Well, you take f of x, and you add c to it. And this is assuming that c is greater than 0. And that's it, it'll shift it up c units. Now, let's say you're going to shift down. F of x. Well, the shift down will just subtract c. And we're still subtracting a positive c here. So if we want this parabola shift down where the vertex here is at -5, do f of x minus 5, and that'll do it. So that's your vertical shift. Horizontal. So let's say we're going to shift left. Well, in this case, that means we have our parabola and what we're going to do, we're going to shift it to -c. Well, we're going to take f and the x, whatever input we choose to x, we add c to it. And again, for c greater than 0. This seems kind of counterintuitive, like we're adding c to go in the negative direction, but that is what it is. Now, let's say we want to shift right. I'm going to shift it out to c. Well, what we do here is we replace f of x with f of x minus c, again for c greater than 0. And again, it's kind of counterintuitive, aesthetically speaking. Subtracting c to move in the positive x direction. Well, that is what it is. All right. So those are the shifts. Next are the reflections. So first one, x-axis. So let's say we have this, again, our parabola. Well, in this case, we have our f of x. You want to flip it across the x-axis like this. That's a reflection across the x-axis. So that means to do this, to flip it vertically, we just attach a minus sign to f of x. We change the signs on the output. All right. So that's across the x-axis. Now, y-axis, now let's say we have y equals x cubed as our f of x. Well, what we do here is we take the x and attach a negative to it. And so if you want to see the result, maybe a little clearer, you can see if you flip this over this side, get this. Flip this over the x-axis, you'll get this. And then take this, flip it over the x-axis, you're going to get that. I'm sorry, y-axis, y-axis. Let me say that again. Flip this across the y-axis, you're going to get this. Flip this across the y-axis, you're going to get that. So that's how we can reflect across the y-axis. Now there's one you want to be careful of. And with this one, like y equals x cubed, you don't have to really think about the domain. You can just choose some x values, plug them in, you'll get this graph. And then when you get over here, choose some x values, and then when you compute f of negative x, you'll take the same x values, but then change the signs on them and insert those into your calculations, and you'll get your output. Keep in mind, keep the original input. The input, the x values will be the same as you've chosen them. They'll just get this extra modification step that gets calculated to give you different y values or output values from over here. So that's what's going to happen. Now there is one thing though with domain. Again, domain, choose some values, use the same ones here. Not always the case. So for example, let's say we have the square root of x. Now the square root of x means we can only use inputs that are positive. So if we want to reflect this across the y-axis, we have to use x less than or equal to 0. While here we use x greater than or equal to 0. Again, we can only take the square root of positive numbers and 0. Here we have to use x less than 0. Because what will happen, these are going to be negative x values. That minus sign will turn that negative input into positive. And then we can take the square root. If we use positive inputs here for x, the positive, it gets modified in the negative, and now you're taking the square root of a negative. So for this one, you actually do need to make a different choice for your domain. Vertical stretch. So again, we have our parabola, y equals x squared. So a vertical stretch means you're just going to pull this thing upward, or maybe downward. We're going to stretch this parabola, like so. And the way we do that, we multiply f of x by a positive c. We make c greater than 1. We'll make c greater than 1 in this case. So that's a vertical stretch. Vertical shrink. Again, we're going to multiply by c. Except this time, shrink it down vertically. And we have c times f of x, or c being some kind of fractional or decimal value between 0 and 1. Now, we don't want to make c negative, because if you make c negative, okay, you're going to have a shrink or a stretch, but then that negative sign is going to give you a reflection across the x-axis. And then if it's c is 0, well, that just eliminates the function. If c is 1, well, 1 times the function is just itself. There's no actual change. Now, this is one of these that might, from an aesthetics point of view, seem counterintuitive. But for a horizontal stretch, then we've got our parabola. To stretch it out horizontally, widen this parabola. We take f c times x for c between 0 and 1. So while for the vertical stretch, you needed c bigger than 1, for the horizontal stretch, you need c between 0 and 1. For the horizontal shrink, f of x, again, it's parabola x squared. To squeeze this in like this, squeeze it in, we take f of c times x for c greater than 1. So again, for the vertical shrink, you multiplied f of x by c, where c is a fraction or decimal between 0 and 1. But in this case, to shrink Horizontally, you use a C bigger than 1. So that's the overview of these different transformations. And if any questions,